Okay, good morning. Today we will start chapter 10, lesson 1, which is talking about the Pythagorean theorem. We will learn how to solve problems using the Pythagorean theorem, and how can we identify the right triangles. So in this lesson, we will talk about the Pythagorean theorem. We will use it to solve the right triangles. All of us know that before we say that if you have a if you have a right triangle here, okay, and each right triangle have a right angle. Now, what is the name of the side that is opposite to the right angle? What did we name it? Who can tell me?
Left triangle.
This is a right triangle, okay? This is the right angle. Now, what is the name of the side that is opposite to the right angle? It is a hypotenuse. Is it right? We talk about in geometry. And this will be a leg, and this will be a leg. So the side that is opposite to the right angle in a right triangle will be a hypotenuse, as we said before in geometry. Now, there are special, wait a minute, please, here. There are special names for the side for a right triangle, like the one in the solve it here. The side opposite to the right angle is the hypotenuse, as we said. If this is a right triangle here, and this is the right angle, the side that is opposite to the right angle, we call it a hypotenuse, which is the longest side. Each of the sides forming the right angle is a leg. So if this is a right angle, the sides that's forming the right angle, we call them leg. And the side that is opposite to the right angle, which is the longest side, as you see, will be a hypotenuse. Look at the length of this side, the yellow one. It is greater than the red one, is it right? That's why the hypotenuse is the longest side. Now, if I know the length of the first leg and the length of the second leg, and I want to find the length of the hypotenuse, how can I solve it? What can I do? I will use the Pythagorean theorem. So the Pythagorean theorem helped me to solve the right triangle. If you know the length of the legs and you need to find the hypotenuse, you will go to the Pythagorean theorem. So the Pythagorean theorem, named after the Greek mathematician Pythagoras, relates the length of the legs and the length of the hypotenuse. They make a relation between the length of the legs and the length of the hypotenuse. What did he say? He said that the lengths of the sides of a right triangle have a special relationship. If we know the length of any two of the sides, you can find the length of the third side. So if you know the length of the leg and the length of the second leg, and you need to find the hypotenuse, you will go to the Pythagorean theorem. Or if you know the length of the hypotenuse and the length of the first leg, and you need to find the other leg, you will go also to the hypotenuse, to the Pythagorean theorem. So the Pythagorean theorem make a relation between the first leg, the second leg, and the hypotenuse. So what is his theorem? In any right triangle. So you must know that the Pythagorean theorem only used in right triangle. In obtuse, you cannot. Or in acute triangle, you cannot. In obtuse, you cannot also. In equilateral triangle, you cannot also. Only in right triangle. So the Pythagorean theorem only used in right triangle. Now, so as we said, the Pythagorean theorem used only in right triangle. Now, what did he say now? Or what is the theorem? The sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. This is a right triangle here. This is the first leg. We name it with A. And this is the second leg. His theorem said that if you take the square of the first leg and the square of the second leg, and you add them, the sum of the square of these two legs will be equal the square of the hypotenuse. So A squared plus B squared equal C squared. Is it clear?
Yes.
Yes, teacher.
Yes, teacher.
Yes, teacher.
Yes, miss.
Okay. Let's have this problem here. In this problem, we will find the length of the hypotenuse. We will solve a right triangle. Look at here, we have a tiles at the right, which is a square, and they have an 6-inch sides. So the length of the first leg is 6 inch. This is the right angle here, and the length of the second side is also 6. I need to find now the hypotenuse. One of you teachers asked me, teacher, how can I know the hypotenuse? Is it this one or this one? Don't forget, look at the right angle. The side that is opposite to the right angle is a hypotenuse. So C will be a hypotenuse. This is the first thing. So we say that A squared plus B squared equals C squared. So you must know which is A, which is B, and which is C. As we said, this is the right angle. Here is a right angle. So this is the opposite, or the opposite to the right angle will be the hypotenuse. So C is unknown, which I need to find it. The other side, one is 6 squared plus 6 squared. Now 6 squared is 36 plus 36 will be C squared. Now c squared will be the square root, or will be, sorry, if you add them, c squared will be 72. But what did I need? I didn't need c. I didn't need c squared. I need c. So c will be what? How can I find c here now?
Square root.
Yes, so I will say c is the square root of, or under square root of both of them. I will find that c is square root of 72. Now, is it only positive square root or positive and negative?
Positive and negative.
Positive and
Positive
negative.
and negative.
Exactly.
Positive
They
and
are
negative.
positive and negative. But so it will be positive 72 or negative square root of 72. But is there a length which is negative? Can I find any length in our real world that will be -5?
No, teacher.
No. So I will say only it is positive square root of 72. So the length of the hypotenuse will be square root of 72. Now, shall I stop here? No. I have to write the unit of the length. What is the unit here?
Inch.
Inch, exactly. So I have to write that c, or the hypotenuse, will be square root of 72 inches. Is it clear?
Yes.
Yes, teacher.
So I will repeat here. This is
Yes,
the
miss.
Pythagorean theorem. A squared plus b squared equal c squared. To solve it, I need to identify where is a, where is b, and where is c. And just then substitute now. We say that to find c, we must look at the right triangle. Where's the right angle here? This is the right angle. Since this is the right angle, the side that is opposite to the right angle will be the hypotenuse. So I need to find c. As I told you, if I have the length of two sides, I can find the length of the third one. So 6 squared plus 6 squared give me c squared. Let's go now to the other example here. What is the length of the hypotenuse of a right triangle? So I have a right triangle here. I need to find the length of the hypotenuse, so which is c, which is here. With legs of length 9 centimeter and 12 centimeter. So I have two legs here, 9 and 12. I need to find the length of the hypotenuse. Let's go to the Pythagorean theorem. A squared plus b squared equal c squared. C is unknown. I need to find it. I have a, which is 9 squared, and I have b, which is a 12 squared, equal c squared. Now, 9 squared is 81, 12 squared is 144, equal c squared. Let's add them now. 4 plus 1 is 5. 8 plus 4 is 12. So it is 225 equal c squared. So c squared will be a square root of 225. Now what is the square root of 225?
25. 25.
No, it is 15.
15, teacher.
600, yes, 625. A square of it is 25. But 225, the square of it is 15. So the length of the hypotenuse here is 15 centimeters. Is it clear?
Yes.
Yes, teacher.
Yes, teacher.
Now, you can also use the Pythagorean theorem to find the length of a leg of a right triangle. What does it mean? In the previous problem, we said that if we have the length of the leg and the length of the other leg, and I need to find the hypotenuse, I will use the Pythagorean theorem. Here also, if you have so here, we can also use the Pythagorean theorem to find the length of the leg. What does it mean? Here, as you see, look at this triangle here. Here, you have the length of the hypotenuse, which is 13. And the length of one of the legs. I need to find the length of the other leg. So here, I have here the hypotenuse. I have here the length of the leg. And I need to find the length of the other leg. Also, I have to use the Pythagorean theorem. So here, a squared plus b squared equal c squared. Now, where is a?
Five.
It is 5, exactly.
5 centimeters.
5 squared. Where is b?
B is
Unknown.
Is unknown. Where is c?
13.
13.
It is 13. That's it. So here, I just first substitute a, b, and c. Then let's solve it here. A squared is 25. B squared, keep it as it is. And 13 squared. What is a square? 13 squared. 13 times 13.
169.
Exactly. It is 169. I need to find b. Here it is an linear equation. 25 plus b. Oh, not linear. Sorry, it is an equation. 25 plus b squared equal 169. So where's the variable here?
B squared.
B squared.
B squared is added to 25. Is it right?
Yes.
Yes. And since b squared is added to 25, so I have to write the opposite of added 25, or which is
Negative 25.
Yes. So here, since 25 is added, I just subtract 25 from both sides here. So then, b squared will be, let's subtract them here. 9 minus 5 is 4. And 16 minus
144.
is 144. Yes.
144.
So b squared is 144. So b will be
12.
square root of 144. What
12.
is the square root of 12? Exactly. So it is a 12 centimeter. Now, here you have, I want you to know something here, that in math we have special triangle. every time if you have this leg here is a 3 and this is 4, every time if the length of the legs is 3 and 4, the length of the hypotenuse will be 5. So this is a right triangle here. We name it as 3, 4, 5. What does it mean? That means if the length of the legs is 3 and 4, so the length of the hypotenuse would be 5. And the other one here, which is 6, 8, and 10. Try it. 6 squared, 36, plus 8 squared. If you try it, you will find that they are 100. And the square root of 100 is 10. And the last one here, if this is 5 and this is 12, this will be 13. Here, just to know, if they are 5 and 12, the hypotenuse will be 13. As we said here, 5, and here is 13. I said 5, 12, the hypotenuse will be 13. If I told you here as an example, if you have a 3 and here is 4, you tell me the hypotenuse is 5. If you have it as 10 and 6, I told you 6, 8, 10. So the length of the leg will be 8. How do you know this one? By the Pythagorean theorem. This is just an extra information. Now let's come back to our lesson here. What is the side length A in the triangle at the right here? Look at the right triangle here. A squared plus B squared equals C squared. Where is A? It is here.
Unknown.
It is unknown. Where is B?
12
It is
squared. 12.
12. Exactly.
12.
Where is C? The opposite to the right
15.
angle.
15.
Exactly. Now, A squared plus 144 equals 225. What we have to do then?
Subtract 144 from each side.
Subtract, exactly. So, A squared will be 5 minus 4, 1. 22 minus 14 is 8. So A squared will be 81. So what is the length of A will be?
9.
9.
9.
9.
So here, in this right triangle here, if this is 9, this is 12, this will be 15. So if you add 9 squared plus 12 squared, you will get 15. Is this clear?
Yes.
Yes, teacher.
Now, let's do this exercise from the problem solving here. Use the triangle at the right. Find the missing side. If necessary, round it to the nearest length. Let's do number 6 first. If you have A here in number 6, if you have A is a 3 and B is 4 and you need to find C, we said E squared plus B squared equal C squared. Where is A? It's the 3. Where is B? It is 4. Is it right?
Yes.
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 Equals C squared. Then 3 squared is what?
9.
9
9.
9.
and 16.
9 plus 16
Yes.
equal C
10
squared.
equal 6 squared.
So 9 plus 16 will be C squared. So 25 equals C squared. So C will be
5.
5. Exactly. Let's do now number 7. In number 7 here we have right triangles. A is 6. C is 10. I need to find B, which is the length of the leg. So A squared plus B squared equals C squared. Where is A?
6.
It is 6 squared.
6.
Exactly. Where is B?
10.
Unknown.
It is unknown. No, it's
Oh.
unknown.
Yes.
And where is C?
10.
10.
It is 10. Exactly. So 36 plus B squared equals 100. Minus 36 minus 36. So B squared will be 100 minus 36. Let's subtract them first here.
64.
10 minus 4, 9, 3. So it is 64, exactly. Then B squared is 64, so B will be
8.
8.
Thank you. So we solve the triangle, the right triangle here. Let's go now to the last one. In 8 here, we have a B is 1, C is 5. What happened here? C here, my God. C here is 5 over 4. B is
Yes.
1. I need to find A. So A squared plus B squared equals C squared. Where is A? Is unknown.
Unknown.
Where is B?
1.
1. 1
And C squared, it is 5 over 4
over 4.
Squared.
squared. Now, so A squared plus 1 squared is 1.
1.
1.
Equals.
1.
Now let's come here now to square 5 over 4. What we have to do? We have first to square 5. What is the square of 5? It is 25.
25.
And then
25.
I square. So after I
16.
square 5, I need to find now the square of 4. What is the square of 4?
16.
16.
16. So the square root of 5 over 4 will be 25 over 16. So A squared plus 1 equal 25 over 16. Minus 1, minus 1. I need here to clear the space here first.
Yes.
So here I have an a squared equals, come back here now, 25 over 16 minus what?
1.
Minus 1. I need now to subtract them as we learn in grade 6. If we have a 25 over 16, this is a fraction, and I need to subtract it, a whole number, I need to subtract it from a fraction. I come to the 1 here, I write it as 1 over 1. Then, as we said,
And
if we
multiply
know
it
to
with
subtract a fraction, we must have the same denominator. So, look at the second one here. The denominator here is 1. I need to keep it 16. So I have to write multiply by
16.
By
is it right?
16.
Yeah.
And
also
since the numerator and the denominator are sisters, if I multiplied the denominator, I must multiply the numerator. So it comes like 25 over 16 minus 16 over 16. Let's subtract them here now. 25 minus 16 is what?
25 minus 16 equals
9 over 16. 9 over 16.
9, exactly, over 16. This is an a squared. I need to find a. So what I have to do now? Under square root, under square root. So a will be here,
3 over
as we did in the square, we have to do in the square root. If you
3
come
over
back
4.
here, we
3
say
over 4.
have 5 over 4. We square the numerator and we square the denominator. Here, we have to put the square root of 9. My God. The square root of 9 over
3.
the square root of 16. So I need to distribute the square root of a numerator and of the denominator. So what is the
3
square
over
root of
4.
9?
3 over 3.
It's a 3.
3
And square root of
Over
16.
4.
4.
Exactly. So
So
a here will be 3 over 4. Is it clear?
Yes.
Yes, teacher.
Yes, teacher.
Yes, miss.
Do you have any question for this part of this lesson or for this period today?